Imagine a moment in time when Earth didn't exist, a time when there was only chaos and cosmic dust. In the vastness of the cosmos, the early universe was a swirling eddy of particles and gases, a kaleidoscope of chaos, teeming with potential. The universe at this time was like an abstract painting, a cosmic tapestry of swirling dust and gases, each particle a tiny brushstroke in a grand masterpiece yet to be unveiled. This was a time of constant, unending motion. Each speck of dust, each tiny gas particle, was drawn towards its neighbors, caught in an intricate dance orchestrated by a silent conductor, gravity. Gravity, that invisible force that holds our universe together, beckoned these particles closer and closer. They began to coalesce, to stick together, forming larger and larger clumps of matter. Picture a snowball rolling down a hill, gathering more snow as it descends. This process, known as accretion, was not a quick one. It took millions of years, each passing moment bringing us one step closer to the formation of something incredible. These growing clumps of matter, these embryonic planetary bodies, were the protoplanets. They were not yet the fully formed celestial bodies we're familiar with today. Rather, they were an intermediate stage, a stepping stone on the path to planethood. The protoplanets were not uniform in size or composition. Some were rocky, others gaseous, some were small, perhaps the size of a modern-day asteroid, while others were colossal, rivaling the size of the planets we know today. One such protoplanet, a rocky body located in the Goldilocks zone of its star, was unique. It was not too hot, not too cold, but just right. It was, in many ways, the proverbial needle in a cosmic haystack. From this celestial chaos, a protoplanet that would eventually become our Earth began to take shape. This protoplanet was the seed, the genesis of the world we call home. Its story, like ours, was just beginning. In the heart of chaos and cosmic dust, a protoplanet was born, a raw version of our Earth. Imagine a celestial ballet where particles of dust and gas dance around the newborn sun, drawn together by the inexorable pull of gravity. As they collide and coalesce, they form larger and larger clumps, until eventually these clumps become planetesimals, the building blocks of planets. Among this cosmic rubble, one particular planetesimal started to stand out. It grew larger and larger, its gravity becoming so strong that it began to attract other planetesimals towards it. This process, known as accretion, is how our Earth began to take shape. At this point, the Earth was a roiling molten mass, its heat generated by the intense pressure of its own gravity and the violent collisions with other celestial bodies. The heaviest elements, like iron and nickel, sank towards the center, forming the core. The lighter elements, like silicon and oxygen, stayed near the surface, forming the mantle and the crust. But this was not a quick process. It took millions upon millions of years for the Earth to cool down enough for the crust to solidify. And even then, the surface of our planet was a hellish landscape, scarred by constant volcanic activity and bombarded by asteroids and comets. Yet despite this hostile environment, the foundations for life as we know it were being laid. The constant volcanic eruptions spewed gases into the atmosphere, creating a primitive form of what would later become our atmosphere. Slowly but surely, this fiery molten mass was morphing into something that we would recognize as a planet. But it was still a long way from being the Earth as we know it today. And so our Earth, a fiery molten mass, was gradually cooling down, setting the stage for the next phase of its evolution. This was the birth of a protoplanet, a raw, unformed version of our Earth, taking its first steps in the grand dance of the cosmos.
Imagine a world of fire and molten rock, a world thirsting for water. But where did the water come from? Picture this. Our Earth, once a fiery sphere of molten rock, devoid of the life-sustaining liquid we take for granted. One theory suggests that water was delivered to the Earth by icy comets and asteroids. As these celestial bodies whizzed around in the early solar system, some inevitably crashed into Earth. When these icy travelers collided with our planet, they melted and released their precious cargo, water. But there's another theory that our planet's water may have been homegrown. This theory proposes that water was actually produced from within the Earth's own interior, a process known as outgassing. Picture this. Deep within the Earth, in the hot, high-pressure conditions, water vapor was formed. This water vapor, locked away in the
volcanic activity. As the volcanoes erupted, they spewed out not only molten rock, but also a steamy mix of gases, including water vapor. Once released, this water vapor rose up into the atmosphere where it cooled and condensed, forming clouds. And from these clouds, rain fell, filling the oceans, rivers, and lakes. Water was essential not only to quench the Earth's thirst, but also to create its atmosphere. The water vapor released from the Earth's interior, along with other gases, formed the Earth's first atmosphere. This atmosphere acted like a blanket, trapping heat and creating a more stable and hospitable environment. This process took billions upon millions of years, but with each passing year, each falling raindrop, the Earth was transformed. From a fiery, molten world, it became a water-rich blue planet, a world capable of nurturing life. With the arrival of water, Earth was no longer a barren, fiery world. It was ready to nurture life. The stage was set for the next act in Earth's dramatic history, the dawn of life. But that's a story for another time.
Water, the life giver, had arrived, but how did life begin on our blue planet? As it turns out, the exact origins of life on Earth are still a mystery shrouded in theories. One of the most widely accepted theories is the primordial soup theory. Picture this: our young Earth 4 billion years ago, with oceans filled with organic compounds like a vast simmering soup. Lightning strikes, and these compounds react to form simple life forms. The idea is that life began in this soup, with these simple life forms evolving over time into the complex organisms we see today. Then, there's the theory of panspermia. It suggests that life, or the building blocks of life, could have arrived on Earth from outer space, hitching a ride on a comet or meteorite. It's a fascinating idea, isn't it? That we might all be descendants of alien life forms. Regardless of how life began, one thing is clear. Once it took hold, life on Earth evolved at an incredible pace. From these simple life forms, over billions of years, sprouted the diverse array of life we see today. It's a breathtaking journey, from single-celled organisms to the rise of complex creatures, plants, and even us humans. Imagine this: the first plants oxygenating the atmosphere, the evolution of complex multicellular organisms, the explosion of life in the seas, the transition of life from water to land, the rise of the dinosaurs, their extinction, and eventually the evolution of mammals and the first humans. It's an epic tale spanning billions of years, full of trials and triumphs, extinctions and emergences. The story of life is the story of Earth itself, and it's still being written. Every new discovery, every advancement in science adds a new chapter to this incredible tale. From cosmic dust to a blue planet teeming with life, the story of Earth's formation is a testament to the wonders of the universe. Our Earth has come a long way, but what does the future hold? Ponder upon this for a moment as we journey forward in time, casting a glimpse into the possible future of our beloved planet. Imagine Earth centuries from now. The climate has changed significantly, influenced not just by natural geological processes, but also by the actions of its most intelligent inhabitants, us, humans. The rising temperatures, the melting ice caps, the increased frequency of extreme weather events. All these are indicators of a planet under stress. But it's not all doom and gloom. We have the power to shape the future of our Earth. We can reduce our carbon footprint, conserve our resources, and protect the biodiversity that makes our planet so unique. Our actions today will determine the Earth of tomorrow. It's a responsibility we all share to ensure that future generations inherit a planet that's as beautiful and vibrant as the one we have today. And while we're busy safeguarding our home, let's not forget that our curiosity and thirst for knowledge have led us far beyond the confines of our planet. We have ventured into the great unknown, the cosmos, seeking answers to questions that have perplexed humankind for centuries. The journey of Earth continues, as does our exploration of the universe. Stay tuned for our next episode where we delve into the mysteries of black holes. These enigmatic entities, which distort time and space in their vicinity, have fascinated and baffled scientists and laymen alike. What secrets do they hold? What can they reveal about the nature of our universe? To satisfy your curiosity, join us on our next cosmic adventure. Don't forget to like, subscribe, and hit the bell icon on Today in Science to stay updated. Until next time, keep exploring. Because the more we learn about our universe, the more we realize how much there is yet to discover. So let's keep asking questions, let's keep seeking answers, and let's keep exploring the infinite wonders of the cosmos.